Hello everyone. What do you think this live session would be about? That's the first question which I want to ask you. 1 second. YouTube. Okay. So, so yeah. First, let me ask you some of the questions for now. So, why does I let me tell you this thing. Why does Insta break doesn't break for even 50,000 likes. I think you understood what today's agenda will be, right? So why Insta doesn't break? So it's not break. Insta doesn't break for even 50,000 likes. Now, there are many scenarios where we use system design actually. And the second thing, millions are buying products across the globe, products on Amazon. Now, imagine you write a Python script and that would be used by millions of users. What will be the consequences and how you would be maintaining that, right? Now, why doesn't the internet break? What are the things for all this? What is the main thing for all these systems? If anyone knew about these things, please let me know in the live chat. Right now, I think I'm audible to you all. Yes. Okay. Now, here, let me tell you how do I relate it to data structures and algorithms. Now, companies like companies like Google and Netflix handle billions of users, right? Not only millions, but billions of users. How do they actually do it, right? So that's what the problem or the scenario or the agenda which we gonna discuss today, right? Now, there is this thing like data structures and algorithms, which is the efficiency of single car, how fast it goes, how it handles turns. But system design is something much like a traffic. So let me tell you, this DSA is something like a car, and system design will be like a traffic. I'll tell you what is traffic and what is load balancing, what is database sharding and all, but if only you would be till the last of this live session. Now, this system design is something like a control system of a whole city, not a street or a road, but the whole city, right? So that's what the system design is much about. Now, let me tell you this with an example, and we'll move on to the next things, right? First, let me tell you, DSA would only get you get you interviews, right? The lead code, the contest score, and also the number of problems, and also the patterns and also you can solve a DSA question if you were asked in an interview. But system design is itself like will make you build systems that doesn't break. I think you are being read, or you are being hearing this breaking or designing or building. That's what the system design mainly is. Now, DSA is something like the data structures which we use for any problem, not only the problem. Like, let me tell you a simple example of the previous data. If you want to store the previous data, where we can store in a way such that the one which is previous, I can get it. So for that, we'll use a stack where the previous one will be on the top. Now, there is this stack, and there will be something like a hash map which will be using much, and also queues for scheduling of CPU, right? So these are some of the things which we need for designing systems and also in coding, right? Now, there are much other things which we're gonna do, which we're gonna discuss in this live session, right? Now, let me tell you one thing. Let me start off the things going into the deep dive of the today's topic. First, what is system design actually? So this is just the process of the system design actually. The system design is actually nothing but defining the architecture and and the components and how they talk to each other, right? So I'll tell you, like, in artificial intelligence, there will be something like a state and also the agent, how these agent and state, what is the goal state, and also what is the environment which is in now. Defining the architecture and also the components, how they talk with each other. That's the thing. That's the thing, right? We divide this into uh, two subgroups, right? The system design, let me divide this into two subgroups, HLD and LLD, which is nothing but high level design and low level design. Now, let us see what is high level design actually is. This is just like the bird's eye view. We talk about the services, and also we need an image. Let me take an example. Like, if we need an image service, a follow service, also a news feed service, we focus on load balancers and databases. Now, in Instagram, I think it would be better if I use what color is Instagram? I don't know actually. So here, if I have an Instagram, in this Instagram, HLD is nothing but an image service in an app. Uh, it might be Instagram or LinkedIn or any other social media app, image service or news feed, or a follow service, something like this, in just like bird's view. We focus on load balancers and databases. That's why we're gonna talk about, right? Load balancers and databases. Now, what does LLD actually mean, right? So, we are good to start with the LLD. Now, this LLD is the guts. Let me write it here. Guts of system. I'll tell you what does all these mean. Let me take an example like inside the image service itself. What does the image class look like? What attributes does it have? Image ID, owner ID, and also the number of likes it got, and also the resolution. We use design patterns like the factory pattern or singleton. I'll tell you all these things, right? Okay. So in image, we'll have the specifications like image ID. It is something like if you see this, these are the services. If you think it as a car, the one who knows HLD is like a uh, an a mechanic of like if an engineer of the car. But when it comes to LLD, he knows about the engine, he knows about the uh, what is the type of the engine, what are the oil change, like something like in a car way, and also something like not the exterior parts but the interior parts of a car. Here it would be like wipers, tires, glasses, something like this. Here engine, oil change, and so on, which are interior to the car. That's how a car runs. Here, how car is actually used, right? Now, I have said that low-level design is the guts of the system. Now, the image ID or the owner ID is the ID who posted that image, and also the resolution which it has. Here, it also includes the braking system. I'll tell you what all these comes under HLD and LLD, which we can differ. Now, when we come to the system design, there will be four pillars of this or the physics of systems. Let me tell you what are all those things. Wait a second. So yes, the availability, the scalability, and the reliability cap theorem, right? Now, what is the scalability? Let me tell you the four pillars, right? Now, the first thing is the scalability. The second thing will be the availability. The fourth thing will be the cap theorem, and the third thing will be reliability. The cap theorem. Now, what does scalability actually mean in a system? Now, let me tell you here. What if you're buying a $20,000 dollar RAM stick? It's easy but has a limit. Horizontal scaling is quite opposite to it. Now, vertical scaling, vertical scaling, and there is also horizontal scaling. To understand it clearly, to understand it clearly, let me tell you with an example, right? So, imagine there are five areas, five areas in a city. In a city, imagine there are five areas. Let me name those uh, areas. As in Hyderabad, I have Kokapet and also Sikandrabad and something like High Tech City, Gachibowli, Gachibowli, and here I have Raidurga. No, these two are away, much away. Sikandrabad is much away from the High Tech City. These two are like, quite less distance compared to Sikandrabad. Now, you have a cafe, uh, a cafe in High Tech City. All those people come from Kokapet to High Tech City and from Secunderabad to High Tech City and the Gachibowli to High Tech City, Raidurgam to High Tech City, and the people at High Tech City also come to your cafe. Now, can you handle these many, what do you say, uh, these many customers? That's what it is. Now, in this cafe, if the load, that's what I call it, right? We call it in the terminology. Load is what I'm talking about. The load is nothing but the number of customers. If it is increased, the load is we just say the increase in load. Now, if the load is increased, then there are two things I'll tell you how. You just make that cafe much larger. I'll tell you what much larger means. Nothing but you scale the right, you scale the cafe in such a way by having more workers, pre-orders, more workers, and also the pre-orders. And there are many much things which you can do. And this is called as vertical scaling. Now, if you open, if you open, if you open multiple cafes in these areas, cafe in Kokapet and a cafe in Sikandrabad and also a cafe in again Gachibowli and a cafe in Raidurga. So this is called as horizontal. I think you have understood what is the horizontal and also what does this vertical scaling mean. Nothing but starting more cafes. That's what the horizontal cafe scaling actually means. Now, the load, I am comparing it with the customers to the cafe, to the cafe. Now, what will be the availability? Now, imagine, just imagine it as something like the nines. Now, let me tell you what is this nines mean. Now, if someone says, your cafe is uh, let's come to the designing topics again. Your cafe is 99.9% really how I would say that 99% will be sounds good, but that is just a 9 hours of downtime. 9 hours of downtime, right? That's millions in loss, millions in loss, right? So that's 99.9 might be sounding good, like looks very good if you are not into system design, but that's 9 hours of downtime. That 99.9 is itself 9 hours of time downtime in an in a year. Now, in a scale like it will be millions in loss, millions in loss. Now, we aim for 5 nines. Let me tell you. Let me repeat that again. So, we aim for 5 nines. 99.999%, which is 5 minutes of 5 minutes of downtime per year. That's it. Now, what is like if you have any doubts, please stop the itself and ask me your doubts. Now, let us see what does the reliability mean. Now, if a server hard drive explodes, does the user lose their food? Right? That's that's the question I want to ask. Now, if a hard drive crashes or explodes, does the user actually right lose their food? Something like if somewhere in an Instagram you have posted a picture of yourself, and if any server had a hard drive crash, would your photo be deleted from the servers of Instagram? That's where the question points. Does the user lose lost their pic? Right. Now, there is this thing which is called as reliability. Even if some loss is happened, right? Let me tell you a simple thing. Now just imagine in your cafe a situation something like a table. Uh, a table has been broken, or something like a chair or a table has been broken. Will that be a major loss, right, for the customers? That's what my question is. But if you have only one table and one chair, that would be a loss of customers. No one will be having only one chair and one table. Imagine there are only two tables in your cafe and there are the 8 chairs in total, two tables and 8 chairs. One table is lost, means four customers lost, right? So that's something like if a hard drive crashes, there should be something like a backup. So many of the cafes run with the insurance, and also they don't dump all their money at one place, right? Now, achieve we if the answer is no, if a hard drive crashes, does the user lose their product? If no, then it's not. reliable. Now, we achieve this through redundancy, nothing but keeping copies, right? So let me write it as redundancy is nothing but the copies of the picture or the data which we have in our systems. Now, what is the cap theorem actually, which is nothing but the hard choice. In a distributed system, you can only have two out of three: consistency, availability, and partition tolerance. Right. Let me explain you what all these things are. So, which is just nothing but the hard choice: consistency, availability, and partition tolerance. No. Mm, right. Okay. So consistency is nothing if the network breaks, nothing but the partition. And do you show the user an old version of their profile, which is nothing but the availability, or show them an error because the data isn't synced yet? That's the hard choice the developer makes. That's the hard choice. Even like uh, many of the users, the many of the developers keep talking that AI can do all the job what a developer can do. But there are many things in system design which can't be done by AI. Let me tell you, if the network breaks, nothing but a what do you call the network breaks? It is nothing but the partition. Do you show the user? Do you show the user an old version of their profile as it is availability, or show them an error because because the data isn't synced yet. The data isn't synced yet, which is nothing but the consistency. The data should be consistent, nothing but the data which the user posted should be saved into our system, which is we call it as the consistency, right? This needs to be this needs to decided by the developer itself. No AI can decide what is necessary for the customer or the user, right? Now, the building blocks, which is nothing but the hardware. Now, let's look at the pieces of the board. Let me tell you these pieces in in a simpler way. I'll tell you how. First thing is the load balancer. Now we are going into the deeper things. Load balancer, which is nothing but LB. Imagine this as a traffic police. This is like when 1 million users hit your URL, the load balancer uses an algorithm like round robin, uh, like any other algorithm, right? So, which makes to distribute these 1 million users. Now, it says user A go to server 1, user B go to server 2, something like that. Now, Let me write the same thing so that we can also make a notes of these 7 days of lifestyle. Now, let me call this as traffic police. If 1 million users access or hit, let's say that as hit your URL, the LB uses algorithm like round robin says user 1 go to server 1, user 2 go to server 2. You might have known about this round robin when you have studied about operating systems, right? Now the database, which is much important. Which database you need to choose for the system you are developing. Database SQL versus no SQL. Let me tell you about these things. We use these SQL if you need ACID properties, nothing but uh, the C food consistency. I don't know exactly right where available. No, not these things. Atomic, atomicity, nothing but in a bank transaction. The uh, what I can say in a better way, right? Okay, let's just go to the next things, right? I'm not getting the exact thing which I can tell you acid properties, right? Atomicity, consistency, and also there's another things. Let us see acid properties. Let me check once. Yeah, I'm just missing those two words. Acid properties in SQL. Okay, a set of four principles. Atomicity, as I said, all will be done or nothing will be done, which is nothing but if a system crashes before commit, we will be rolled back uh, to the initial state. That's what the atomicity is called. And consistency is nothing but, how can I say this clearly? Something like if there are two transactions happening at once on your bank account, the amount which will be displayed, the net amount should be same. No, there will be isolation and also the durability, but we'll be going with the system design concept instead of the database concepts. Now, when we need to use SQL and when we have to use NoSQL, right? So, when ACID properties are non-negligible, negligible, like bank transactions, there is no negotiation for ACID properties in bank transactions, right? There will be logging system in also DBMS. No, no SQL with MongoDB or Cassandra for high volume data. I'll tell you what it means. Let me tell you, right? No SQL for high volume data, which is nothing but when you need this will be when you need for large data, something like Instagram. It will tell you have liked a post of a person, something like there is a crash and your like is not displayed or your like is not stored in the database. Something happened as the system or the network crashed, it doesn't matter much. But if there is a system crash when you are doing a bank transaction, they the the importance of your money and the bank transaction is much more than your like for an Instagram post. That's why we use ACID properties for the bank transactions, nothing but SQL for bank transactions. And the data which we store in SQL is way much lesser than the data we can store with NoSQL. Now, there will be something like SQL is like it is a vertically scalable data, and NoSQL is horizontally scalable. So let us see. In SQL, I also need something like entities, the table data, but NoSQL you can use this NoSQL with documents also. Now, what about the cache, which is nothing but the speed hack? Imagine in caching, let me take it as example, hack, speed hack, where we'll be having hard drive takes 10 milliseconds, right? So reading from the hard drive takes 10 milliseconds. Reading from RAM, Redis takes 0.1 millisecond. We store the top 10 trending posts in the cache so the database doesn't have to work so hard. Something like, let me tell you, if you are having again a cafe, you are owning that cafe. Now, the other things like cold coffee, cold coffee, or something like in cafe, what we need to think about cappuccino, something like that. And the other way you have coffee and tea. Now, the most ordered in your cafe is coffee and tea compared to cold coffee and cappuccino. What you will do, you'll just take a flask which will be having something like this, and you store coffee in that. Every time there will be an order of coffee, you just take that coffee cup, and take the coffee into the cup and just give that order, right? Now, this is called as the cache. Now, there's another thing which is nothing but the distance solver. Let me tell you, CTN, the distance solver. So, if your server is in New York, but and the user you are in India, the data has traveled 10,000 miles, which is much slow, right? A CDN puts, now what, let's see what does a CDN do. What does a CDN actually does? Now the CDN puts a copy of your images in a server in Mumbai. Now the user gets the image in 10 milliseconds, right? Nothing but instead of traveling 10,000 miles, might it is much slow. The CDN puts a copy of your images, nothing but your data or your Instagram post, something like that, where you can get much easily, which solves the traveling cost of the network or the data. So let me write the same thing. If if the user is in uh, in Hyderabad and server is in New York City, New York City, and data has to travel 10,000 miles, which is much slow. Now, instead, what we do, this CDN does is it stores a server, a copy of the data in a server in Mumbai. That's how it travels less distance, and it also will be much faster than traveling from the New York to your place, like Hyderabad, right? So I think that's all for today's session, which is much uh, low and also only 40 minutes that we got into this lesson. But let's go with the case study from tomorrow, and we'll be building instead of having the topics and also detailing about the topics. Now we'll be spending 20 minutes on having any doubts. So